So far we have provisioned the servers. After provisioning the servers, we have set up Cloudera Manager. Using Cloudera Manager, we have configured HDFS, YARN, after which we have enabled high availability for both of them. Once that is done, we have set up Spark, both 1.6 as well as 2.3 onto the cluster. While HDFS is file system, MapReduce and Spark are distributed processing engines which runs on top of YARN. These are primarily the low-level components when it comes to big data. On top of them, there are different tools which can be leveraged by different set of stakeholders with respect to big data applications. One of them is nothing but database engines. So we have several database engines, Hive, Impala, Presto, etc. But when it comes to Cloudera distribution, we typically use Hive or Impala. While Hive uses MapReduce to process the data, Impala have its own way of processing the data. It neither uses Yarn nor MapReduce2 nor Spark. It have its own set of daemons which will be configured on all the hosts. That being said, here is the agenda for this topic. We will first set up Hive and Impala. Then we will validate Hive and Impala. After validating, we'll actually look into components and properties of Hive. We'll see how to troubleshoot issues with respect to Hive. Then we'll actually go through Hive commands and queries at a higher level. We'll not deep dive here because it is not that important for administrators to have advanced knowledge of these Hive queries and commands. Then we'll see different query engines that can run on top of Hive. Hive also have a component called Metastore. So all these query engines, even though they run using different components to process the data, they use something called Metastore, which is configured as part of Hive itself. Then we'll actually look at components and properties of Impala. Then we'll actually see how to run queries using Impala at a higher level. HiveQL is an abstraction over MapReduce like Pig, and interface is more similar to SQL. So you write SQL style queries to process data. You don't need to struggle with low level APIs such as Hadoop MapReduce Java based APIs or Spark based APIs. However, Spark, we typically mix the SQL with other aspects of coding, and then we will build the solutions for our problems. Similar to Hive, Impala is also a query engine, but instead of MapReduce, it uses different approach while processing data by running queries. We can accelerate the application development in Hadoop ecosystem using Hive by writing queries, which will generate MapReduce code to process data. Even with respect to Spark also, if you use something called Spark SQL, which is very similar to Hive when it comes to syntax, but uses the Spark executors to process data, the development process can be faster. That being said, now let us talk about cluster topology. So we have gateway and management service running on Big Data Server 1. There is no change to it. We have masters and slave components. When it comes to masters, with respect to Hive, we will set up something called Hive Server and Hive Metastore. When it comes to Impala, we will have Impala catalog on the same host where Hive Metastore is running. Impala catalog uses Hive Metastore to perform semantics and syntax checks. And then we also have Impala State Store, which will actually keep track of all the Impala daemons which are running on worker or slave nodes. So Impala State Store and Impala Catalog are the master components. And to use Impala Catalog, we also need to have that Hive Metastore DB, which we'll be setting up as part of Hive setup process. Then on slaves or worker nodes, we have Impala daemons configured. And these are the ones which actually take care of processing your data whenever you run SQL style queries. Now when it comes to learning process, downloading and installing is taken care as part of setting up of Cloudera Manager and then CDH. We also can use parcels, and we have seen how to migrate packages to parcels while adding Spark2 to our cluster. Then when it comes to configuration, depending upon the architecture of these components such as Hive and Impala, we have to plan. So Hive has three components. One is DDL or physical modeling, where we will be issuing create table commands, alter table commands, etc. DML, where we will be issuing load and insert commands to load or insert data into the tables. And then HiveQL, which is nothing but query engine, where we will be writing queries, and those queries will be compiled into MapReduce jobs if it is running in MapReduce engine, and then it will actually process data. As it has three components, all the three components use the metastore in one way or the other. Metastore is the one which actually contains the metadata of the tables that are being created as part of Hive. Typically, we use MySQL database for this metastore, but we can configure any other RDBMS also, like Postgres, Oracle, etc. So we need to configure Hive metastore server, and it will be taken care on Big Data Server 4 in this case. To interact with Hive metastore, we also need to have Hive server, and hence we'll be configuring Hive server as well. Once they are done, we will actually go to the configuration files with respect to Hive. They are nothing but hivesite.xml, and there are additional properties files which can be used at runtime, and that is nothing but .hiverc. We will see at a later point in time when we actually set up Hive on this cluster. Then comes Impala. Impala have both masters and slave components, as it does not use MapReduce. It also have three components. One is DDL or physical modeling, second one is copying data, and third one is querying data. Again, all these three components will actually use Hive metastore in one way or the other, because to run queries, we need to have metadata for syntax and semantics checks. For that reason, all these DDL, DML as well as query commands use Hive metastore in one way or the other. But when it comes to Impala, the architecture is master-slave architecture. We need to have additional components such as Impala state store, which keep track of the slave components, and then Impala catalog server, which will perform syntax and semantics checks of your queries, and then Impala daemons as slaves. So this is configuration of Impala. Then we need to understand details about our service level logs so that we can troubleshoot the issues. Typically, when it comes to Hive, we'll have log files with respect to our service under varlog Hive, and with respect to Impala, it should be under varlog Impala. We'll confirm once the components are added to the cluster.